Okay, another run at Newton's method. They give us a quadratic this time, and this doesn't factor nicely, so we can't just pick off the solutions that way. But I did use the quadratic formula on it, and I got the answers just for fun, so the exact answers, or as exact as I could get with my calculator, are these. We'll tuck those away in a corner, and as Newton's method converges, hopefully we'll see one of those two numbers emerging. So let's see how this goes. Newton's method, to remind you, says once you have your initial guess, your next guess is going to be current guess minus f of current guess over derivative at current guess. And where last time I was free to pick any initial guess I wanted, this time they tell us thou shalt use an initial guess of 6, x1 equals 6. So we start there. I'm going to move that over to the left. So if we follow our formula, it says the second guess should be the first guess minus. Now we take 6 and plug it into the function, which will be 36 minus 30 is 6, minus 7 is minus 1. And the derivative at, we need a derivative, don't we? Our function is x squared minus 5x minus 7, and so our derivative, we're calling it f prime. I should use that notation here. Our f prime of x is 2x minus 5. So if we're putting in 6, double that, you get 12, subtract 5, and you get 7. So 6 plus 1/7 is 6.142857, repeating. I'll just stop right there. That should be enough decimal places. So look at that. From 6, it just pounced on it, and it's already corrected 2 decimal places on the very first iteration. If we run this again, you can see it actually went up a little too far. From 6, it went to 6.1428, which is more than the target answer. So it'll be interesting to see in the next step if it actually realizes that and starts dropping down. This time it overshot a little bit, so let's see if it can correct itself. Third step. Okay, so now we're taking our original guess. I'm going to write it 6 1/7 just because that's a little more compact. Or, no, I'm not. Heck with it. It's going to turn decimal soon enough anyway. Let's just live with it. 6.142857 minus the function value at 6.142857. Furious punching of calculator keys. 6.142857 and minus 7. And this comes out to 0.020407 over, and the derivative there is going to be 6.142857 times 2 minus 5, which comes out to 7.285714. So if we run all that, 6.142857 minus 0.020407 divided by 7.285714. Now we're at 6.1400. What have I been doing here? 5, 6. I guess 6 decimal places is probably okay. That's a lot of precision. So after the second iteration, 6.1400 is a perfect match. It's got the 5 also, but where the actual answer should be like 5.5 if you rounded it, this one's 5.6. So it's very slightly too high, but it did recover. After going a little bit above the actual answer, it now pulled back towards it. And if we ran another iteration, it should converge even more. It should get closer every time we run it. But they said to just do third approximations, so if we count this as our first approximation, that's the second, this is the third, so we are done.